Hi learners, I am Teacher Ken. Welcome to our lesson today. I'm grateful having you, and we'll be continuing from where we left from the previous video. And it's a continuation because, as you can see, I still have my periodic table intact. And the previous time we were talking about the periods and the groups. We discussed a lot on that, and so I have the confidence to continue and pick up from there. At the end, we mentioned the groups with their names. Each and every group will have names, but at this level, we will study only four groups. Four groups will be studied. So it will be the very first group here, and you call it the alkali metals. The second group, the alkaline earth metals over here, starting from beryllium, and group 7, halogens, fluorine and chlorine, and some other elements down there. And then the last group, group 8, the noble gases. The very last group, group 8 or group 0. Those are the groups that will be under study. It is the topic goes with this name, chemical families, patterns in properties. That is the topic, because you'll be studying about chemical families, their properties, and also we also touch on period 3 elements. Period 3 elements, this one. So in the long run, it will be just the study of the periodic table. It is a big dive into the periodic table, but now with a different name. But that is why I still have my periodic table intact, because we'll be studying more of the periodic table. But the topic is chemical families, patterns, and properties are from 2 syllabus topic. So welcome, and I hope that we get the best from this. I hope that we go together. I'll try to keep the pace. Maybe that if there's something to understand, I pause for a while and maybe make you digest it. And for now we go straight forward, and then by the end of the topic, we will have achieved our objectives. So I'll start by defining or just mention groups. So we said that, okay, remembering what we had said earlier, so that you can continue. We said that a group contains of elements. Let me take an example of this. Hydrogen, lithium, sodium, potassium. A group contains elements that have the same number of energy levels, that has the same number of electrons in their outermost energy levels. The same number of electrons in the outermost energy levels. So lithium has a configuration of 2,1, sodium has a configuration of 2,8,1, and potassium has a configuration of 2,8,8,1. And now they were grouped, or they were plotted to be on the same group of the periodic table, because they have one electron in the outermost energy level. That is what is referred to as a group. And so each and every column here is a group. Every column is a group, and we have just given them names. So we'll be looking at each of the groups with their properties, starting with alkali earth metals. Something else to mention is that group now can be referred to as a chemical family. A chemical family. And it is a family because the elements contained are of the same physical properties. They have similar physical and chemical properties. They may change a little bit, but they are similar. So that is why it is called a chemical family. So all these, the four of them, are chemical families. Okay. So there are some properties that we'll be checking out. I want to write the properties here so that you can discuss them in wholesomely. So I write them here, and then we start discussing from the first group to the last group, and then to the period 3 elements. Let's go now. So we have talked of alkali earth metals. Sorry, alkali metals, and they should not be confused by the other group 2, which are called alkaline earth metals. Remember, this is alkaline metals and not alkaline metals. No, if I say they are alkaline metals, I'll be heading to the wrong direction. So the properties that we'll be discussing about each and every of those chemical families will include, the first one to look at is the energy levels. The energy levels of the atoms. Secondly, we will be looking at the atomic radius, ionic radius, and also comparing both comparing the atomic radius to the ionic radius. Yes, so let me write it here: atomic radius, atomic and ionic radii, that's the plural of radius, radii, and its comparison and comparing them. That is the second thing that we'll be looking for each and every of those chemical families. The other one will be we have talked of energy levels, atomic and ionic radius. Let me write them from my list here. We have ionization energy, ionization energy, we'll be looking at their melting and boiling points. Melting and boiling points. Also, we'll check at the electric conductivity or electricity. Electric conductivity, electricity conductivity, that one. And lastly, their reactivity, how they react, and which is more reactive than the other. Reactivity. These are the properties that we'll be checking for each of those chemical families that we had written here, the 4 of them. Yes, we are not good to go. Those are the properties that we'll be checking for. So we are starting with alkali metals, and to name them alkali metals now, we said that hydrogen will be an exception. Yes, it may be placed in group 1, but now it is not a metal, so this one will have to excuse us. Hydrogen. We are left with lithium, sodium, potassium. We will be left with lithium, sodium, potassium, lithium, sodium, potassium. And just to mention, the others that fall below potassium in the group include calcium, radium, francium, and radium, rubidium. Just to mention, because we won't be studying more about them. This is how group one looks like: lithium, sodium, potassium, rubidium, calcium, and francium. Those elements. Those are group 1 elements. Now we'll be starting with the number of energy levels in these elements. Now coming to this, we'll not be considering these ones that belong to the first 20 elements of the periodic table. We leave out these ones here. We leave them out because we won't be studying them. No, we need just a little amount of knowledge for now. So we'll be running the ones that included in the first 20 elements, and here they are. We want to see the number of energy levels. It can be seen or it can be shown by the electronic configuration. Lithium has 2-1, sodium has 2-8-1, and potassium has 2-8-8-1. Each of these represent an energy level. So lithium has 2 energy levels, sodium has 3, potassium has 4, and of course it means that the elements that lie below potassium keep on increasing their number of energy levels. So we can say that energy levels for alkali earth metals increase down the group. Yes, that is it. Energy levels for alkali metals increase down the group. Maybe it can be shown by diagram, whereby we can draw the atom of lithium, that is the nucleus, and then we said it is 2 1. So we can write here lithium and then show the configuration. It is atomic number 3, therefore it has 3 electrons. It becomes 2 and 1 in the second energy level. That is lithium. Let us show that of potassium. Potassium is atomic number 19 with the symbol K. Potassium atomic number 19. Therefore, since it is atomic number 19, the configuration is the maximum number of electrons in the first energy level should be 1. In the second, it should be 8. That is a total of 10. In the third, it should be 8. That is 18. We are left with 1 electron that falls in the fourth energy level. So in short, it has 4 energy levels. 1, 2, 3, 4. I just drew it. I write the chemical symbol for potassium over here. Good. And then I'll show the electronic configuration. 1, 2, 3, 4, 2, 8, 8, 1. Let me show using a cross. 2 and then 8. 1, 2, 3, 4. Over here. 5, 6, 7, 8. 2, 8, and then another 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 8, 8, and then 1. Let me write it here. 1. So we are just talking about the number of energy levels. It can be shown, it can be seen. This one has just 2, 1, and 2, while potassium has 4. 1, 2, 3, 4. If we reduce that of sodium, it could have 3. 1, 2, 3. Therefore, energy levels for alkali metals increase down the group. Yes, they increase down the group. Done. The atomic and ionic radii and comparing them. So, the atomic and ionic radii. This was the name. So let us start with the atomic radii, and you have heard of the term radius. You have done it in mathematics or somewhere else. And radius simply means for circular objects, it is a distance from the center of a circle to the edge. The distance from the center to the edge is called the radius. That one you did, that one you know. Now, for lithium, or for the atomic radii, for the atomic radius will be the distance from the center of the nucleus. The innermost part is the nucleus. The distance from the center of the nucleus all the way to the outermost energy level. This is the outermost energy level for lithium. This one is the outermost energy level for potassium. The distance from the innermost part to this end is called the atomic radius. That one. For potassium, the same. From here to the edge, that is the atomic radii. Atomic radius. Therefore, if we drew for sodium, it could be the same case, only that it is bigger than this but smaller than this. So, comparing the atomic radius for these atoms of elements, for the atom of lithium and for the atom of potassium, the atomic radius increases down the group. And this is what we mean by saying down the group. It simply means an arrow downwards, down the group. Down the group. So atomic radius for alkali metals increases down the group. And not only for alkali metals. For atomic radius, it will be a bit easier. It will be for all of the groups, from alkali metals then to alkaline earth metals. It will also increase down the group, since there will be an increase in the number of energy levels. So you can guess, for an atom like calcium, it has some more energy levels, more than potassium. Therefore, it has an even higher atomic radius, because they'll be increasing down the group. They keep on increasing. So you have seen, for all the 4 groups, alkali metals, alkaline earth metals, halogens, noble gases, all of them have the atomic radius increasing down the group. Okay, that is good. Let us go to the ionic radius. How does it change, or how does it behave down the group? And when I say down the group now, if I use the term up the group, yes, I can use up the group and say that this one is big, this one is bigger. Sorry, this one is big, bigger, biggest. Yes, it means one is big, this one is even bigger, this is the biggest. But now when I talk of the term up the group, maybe I've decided to use the term up. So it means that when you're going up the group, the atomic radius decreases. Yes, because we have the biggest one at the bottom. If we go up the group, the atomic radius decreases. Yeah. So done with that, let us go to the ionic radius. This is the atomic radius. And now talking of ionic radius, you learned previously of how ions are formed. Yes, of how ions are formed. And ions are formed when an atom loses or gains electrons. We have atoms here. If they lose or gain electrons, then we form an ion. You talked of cations and anions, where one is positively charged, the other one is negatively charged. That's not our topic today. I wanted just to mention about it. But now, in this case now, lithium and potassium and also the rest of group 1 elements form ions by losing electrons. We can agree on that, since they only have one electron in the outermost energy levels. Lithium got 2 1. Potassium got 2 and a configuration of 2881. And for it to form an ion, it must be electrically stable. Yes, it must be electrically stable. And to be stable, it either has to gain an octet or duplet. Is it duplet? Yes, an octet or duplet state. Yes, it either has to gain this or this state. And for in short, it means that in this last energy level, it must have eight electrons in the outermost energy level. And for that to happen, it either has to lose this one, it loses that one, or it gains 7. So that it can be 1 plus 7 to become 8. A lot of energy will be required for 7 electrons to be gained. A lot of energy. Yes. Therefore, instead of gaining those 7 electrons, they lose 1 electron. Yeah, it will lose 1 electron to form an ion. It will be losing 1 electron to form an ion. And therefore, the same case to lithium, the same case to sodium. In short, these two elements or atoms will form ions by losing 1 electron. And what does it mean to lose 1 electron? What will it mean to it? It means if I lose this electron, it means that this energy level exists no more. It exists no more. If it loses 1 electron, it does not exist any longer. And therefore for lithium, it will lose this electron. And the ion will look like this now. That is the nucleus of lithium atom, or now ion in this case. And then it will only have 1 energy level since it lost 1 electron. It will have 1 energy level like that with 2 electrons. So now it will be lithium ion plus, and then a configuration of 2. The same case to potassium, loses 1. This will be the ion now, potassium ion, lost 1. So the configuration is 288. It means 3 energy levels. 1, 2, 3. 2881. Let's do them. 2 and then 8 and then 8. Yes, that will be the configuration or the diagram representation of potassium ion. Potassium 288. 288. So we want to compare atomic. First, you want to see the trend in ionic radius of alkali metals ions. The ions of alkali metals, in this case we're using lithium and potassium, the trend in the ionic radius. So if we drill that of sodium, it will be in between these two, the sizes. But the case is the ionic radius also will increase down the group. This one is a small ion. Yes, it lost one electron, but each and every one of them will be losing one energy level, or one electron, which will be equal to one energy level in this case. It lost this one to remain with 2. It lost this one to remain to 8. That means the ion of this will have one energy level. The ion of this will have 2 energy levels. The ion of this, if it loses one, it will have 3 energy levels. That means the ionic radius is increasing down the group. Yeah, the ionic radius is increasing down the group. Done. The other part is you want to compare. That one will not apply in each and every one of the groups, so let us not use that assumption. Even the other one is not good, just saying yes, it is true. But to avoid confusion, let us know that atomic radius of alkali metals increase down the group. Ionic radius of alkali metals also increase down the group. It has to be done in this group, then to the next. Okay. Atomic, ionic. Now let us compare the atomic radius to the ionic radius. This is the ionic radius, this is the atomic radius. Let us compare the two. We have said that the configuration of lithium atom is 2-1. The configuration of lithium ion is 2 because it lost one electron. This one has 2 energy levels. This one has 2 energy levels, 2-1. This one got only 1 energy level. We want to compare the atom, the size of the atom to the size of the ion. That is visible from afar because this one has 2 energy levels, one has 1. It means that the atomic radius is greater than the ionic radius. Yes, this one is smaller. The atomic radius is bigger than the ionic radius. Now you can use now the vice versa of those words. Greater. If I'm using this one, I say it is greater than lithium. If I describe this one, I will say that the ionic radius is smaller than the atomic radius. Now to avoid confusion, you can pick the one that you prefer. For me, I would prefer saying that the atomic radius is greater than the ionic radius. And how can you describe that? That is just a saying. Maybe sometimes you're given 2 marks to state and also to explain. So the first mark is on saying that the atomic radius is bigger than the ionic radius. And the next step, you say that this is because the atom forms the ion by losing electrons, whereby it loses an energy level, becoming smaller than the atom. The same case here. This one got 4 energy levels, this one got 3 energy levels. The ion is bigger, sorry, the atom is bigger than the ion. We are comparing the atomic size to the ionic size for alkali metals. So in each case, for lithium and potassium, we have seen that in both cases, the atom is greater or has a bigger radius than the ion, simply because the atoms contains more energy levels than the ions. That is a simple definition, and you got it right. The atom contains more energy levels than the ion. Yes, that is done. Ionization energy.